Hello, welcome back to ARC 172 YouTube drawing demos for LAID Spring 2020. The last video showed basically the construction of the cube. Well, the first video is construction of the cube. The second video was transferring our information to the cube. And so now we have the 3-inch axonometric cube with crop data on the bottom and the back. So the next step, the next assignments are going to be extruding that data from each face, both positively and as a negative subtraction in the cube itself. So imagining that as a solid cube with those pieces taken out. The first step to both of these is constructing the wireframe data, and so that's what I'm about to do. And then I will do overlays on vellum, likely, to do the final hidden line versions of these. Okay, so let's give it a shot. Okay, so here is our reference data for this. Actually, it's oriented like this, right? So we're going to extrude the figures. So we have a very complex figure here that kind of just runs all the way through here. So rather than starting with this, let's start with some simple shapes. So let's start with this square shape here first. This should be easy because it's directly on the edge, so we don't need to project it to the edge in order to pull up the lines. So let's start with that piece of data there. So remember that the only thing you can trust in terms of measurements is the actual cube itself. So don't try to eyeball it. Oh, it looks like it comes up here. You want to basically be always pulling data to the faces in order to ensure that you're projecting accurately. So this one is already on this front right face, right? Basically this edge of this this square touches the face here. That edge, the edge here, is already on the edge. So that shouldn't be too hard to do. So let's basically start by pulling this line up and over. And I basically only need to bring it to the point where that would intersect here, but I'm going to pull it all the way across because I have other pieces of data that might occur along that same line. And also having the data pulled to the edge helps you figure out how the data is interacting with the stuff on the back. So that is the only thing I need to project because this is on that line and those two are already on the back edge. So then I can draw the data up. This is already the edge of the cube, and this is the corner at the back. So because this is a 45-degree axonometric cube, if you have a square shape, basically those lines are going to overlap. This is a little bit out of square, a little bit wider in this direction than it is here. So that's why this line comes a little bit further, but that's all I need to project up from the bottom. So that is the wireframe data of that. So I will do just a quick demonstration, and this you'll want to do it with all your data, but I'll do a quick demonstration of what that looks like as both positive and negative data in the wireframe, or sorry, in the wireframe. So I'm going to use my my F lead, just 2F lead. And because this is just a quick demo, I'm just going to do 2 corners of the trace, but you guys will probably do all 4. So, showing that as a positive data is probably the easiest one to see. Basically, you're going to draw all of the edges that are not hidden by the other edges. So all of these you want to construct basically from front to back. So you want to draw the lines that are in front, and then it's probably going to include others. So that is the hidden line version of that piece of data. Notice that the line in back here, that's the back edge, doesn't show, nor do these two bottom edges. So that's fairly simple, I think. And then to do the, I'll just use the same tool of trace. To do the negative version of that, we imagine that the cube itself is solid, and that is being taken away from it. So a solid version of the cube basically does the same thing that what just happened, what we just did with that piece of data, which is it becomes, you see all these front-facing edges. Here we're going to remove that corner represented by that data. And because this line is just a little bit inside, like I said, the cube, that piece of data is not quite square. And you're going to see a little bit of an edge there, coming up to there, and a tiny bit of this edge going back. Okay, so positive, negative. Now this is just to demonstrate using one piece of data, but we're going to add the rest of the data in the wireframe. And you can do it the same way I'm doing it, like test as you go. But let's go with this next. So we just did this piece of data. Let's go with this one because it's still rectangular, but it's not on the edge of the cube. So we have to basically pull these lines out to the edge of the cube. They're already pulled because of the grid, but we have to pull those lines up and over. So let's do that. Let's add that to our wireframe. So this is going to come up. And that represents these 2 points on that rectangle. Pardon me. This is going to come up. That represents those 2 points. So we can pull these across. And then we can pull that data from here. Sometimes you might have to track back, like which of these vertical lines, so this to here to there, which of those lines that I pulled up from the bottom does that represent, or are those points falling on? No big deal. And then let's see, the next 2 are from here up to here, from here up to there. And if I did that right, these should connect to make a rectangle at the top. Which, luckily, they do. So, I'll go ahead and add them to this, but again, you're going to do a complete additive and a complete subtractive. But if we were going to add that to these, then, again, these are 2 separate drawings. I probably should have done them on 2 separate sheets, but the additive version of this data is basically the same idea, the hidden line version showing just those front faces that are not hidden by the other faces. And you can see that as this gets more complex, you might have other shapes that you're constructing that would hide these shapes because they're in front of them. So you definitely want to start the drawing as you're doing it, the hidden line versions. You want to start it from this front corner and kind of work your way in. because you know that these are going to be in front of anything back there. You don't want to start in the back corner and work your way out. So that is the, I don't know if I can hide that, but this is the additive version of those two pieces of data. And then we're going to do it on a larger sheet, the final versions. But the subtractive, if you add the subtraction of that to this, then it would look like this. Just a little incision in the top there is all you would see, because the rest of the cube is unperturbed by that. So this is the additive version, and this is the subtractive version. I think probably what you should do for the finals, and I'll pause this video in a second and try to do a high-speed video, if I can figure out how to do that, of all the data all together. But I think you'd want to do, like, take probably a 9 by 12 piece of vellum. You should have 24 by 36 sheets that you can cut into smaller 9 by 12s, and then basically do on half the sheet do the subtractive version, half the sheet do the additive version. Okay, so I'll pause the video here, and then I will continue with a kind of speeded up version, so you don't have to sit through me drawing for 40 minutes. Okay, so there's my wireframe data. You're probably asking yourself, why did I do it that way? It's so much more confusing to basically see through everything. It's harder to see objects, quote unquote objects. And actually that's kind of the point, because we want to be able to see both possibilities. We want to be able to see them as positive and negative. So it'll take a little bit of time for your eyeballs and your brain to adjust to that a little bit, but if you just take it step by step, then it should work fine. The first is we'll do the positive data. And not all of this will show up, right? Because a lot of this is going to be hidden by things that are in front of it. So you want to start from this front corner and we'll work our way back towards the inside. So we'll start with positive data. So that means that all of these black figures, that's the right orientation. All those black figures are going to become solid volumes as they come up. So I have taken a sheet of 11 by 17 vellum. You guys, like I said, probably want to do 9 by 12, but I've divided it in half and then further divided the halves in half. You should do the same and basically tape down your drawing so it's basically 2 inches from the bottom to that piece and then the center line aligning. So let's go ahead and tape that down. And we will do our positive version first. So I'll do a little bit of it and then I'll go to the fast forward video style that you young kids like so much these days. So let's start in the front corner. So the front corner is going to be a void here. So let's just go ahead and all the lines are drawn. So that's why we're switching to vellum, because you shouldn't need to construct anything else if we did this correctly. So this line is going to come up, and this line is going to come up, and this line is going to come up. And probably not the most efficient way to do it, but as I go, I like to actually complete faces so that we can start to see the thing, because I find that as you start completing faces, it becomes easier to do the rest because you have relative relationships that you can work with. So that is an open corner at the front, and then basically we'll do this next piece over. And we won't see that portion because that's hidden by this front face. So the next thing we will see is this coming over and forward. So let's do those two faces. And then we have this shape that runs here. That goes all the way to here, I believe. Yes. Let's complete that face. And then go ahead and complete that. On the top, that's that figure. And then we have this T-shaped piece here. The front portion of that is here. So you will never go wrong if you just basically complete all the faces that are touching the cube first. But again, I like to try to work my way through and kind of build it so that I can start to see it. Looks like that one is almost right at the edge. I'm not sure if that's coming up. this little rectangle is on the front face as well. It's probably right on the same line there. And here. Okay, so that's the front face. I'm going to pause the video and I'll do the rest in fast motion. Okay, so, oops, I see that I missed one here. So that is the additive version, where basically all of the solids, or all of the figures, the black shapes, come up and become solid volumes. Obviously everything is 3 inches high, but we didn't measure any of that. We used the cube. Anywhere that there is a void or subtraction, you're going to see the vertical lines coming down until they are occluded by the other shapes that are in front of them. Oops, I see another line that I missed right here. Do you see any others? That's basically it. So that is the positive version. I like to basically like to pop the volume, so I like to actually come in and put a profile line around these things so you can see how that works. I'll do that in fast motion as well. Okay, so that is the positive version of the cube. Again, the profile line around the perimeter just helps pop, especially kind of the areas where you start to get those voids into the cube. Once you have holes in your cube, when the data on the back is interacting with the data from the bottom, it gets a little more interesting. But let's do a quick version of the negative data. So this again is where it helps to have your wireframe data, because then you don't have to reconstruct it, and you can prove to me that you can see it either way, either solid or negative, just from the wireframe data. Then you don't have to reconstruct everything. You can basically just use the wireframe data you already used to draw the opposite. So one way to think about this is if the one on the left was basically the solids coming up as extrusions. Oops, sorry. I think it's like that, sorry. this is the inverse, right? So either think of it as this being subtracted from the overall cube, or another way to think of it is you can think that it's the negative space extruding, right? Like that's essentially the same as the positive space being subtracted from the cube, okay? So let's take that down fully, actually. Let's see. I think I have to tape this under. So I will, again, pause the video and go to kind of the accelerated mode and come back after that is done. Okay, so we have our negative version done. Notice the profile line, because the subject data has more solid or more black figures than white ground, then basically the negative version ends up actually having less volume in it because essentially you're doing a solid void reversal by subtracting the black data. You're going to end up with basically just the white data in place. So that is essentially the next assignment. We will do that on the bottom, from the bottom, and also from the back. There's nothing different about the data on the back. You're still going to do a separate overlay like this to do your wireframe data, but instead of, actually maybe I'll do a quick version of what that looks like coming from the back, or at least a piece of data or two. I think this is getting into hour 2.5 or hour 3 of filming, so don't want you guys to get bogged down in videos. So, being very stingy with my dots. Who knows when the dot shipments are going to come in. So going back to my non-photo blue, same idea, you're pulling the data out and around. So basically with this, we only have 1, 2, 3, 4, 5, 6 points here. So we're going to pull those out. I'll just do these first couple rows, just to make sure you guys have it. Maybe I'll just do that piece, that one corner piece of data, just so you can see. The only difference is the parallelogram in the back, but again, everything is still true, so all the dimensions are still true. No difference in that. So basically you would pull this piece over to represent those 2 points, pull that down, and then that gives you essentially the replication of that rectangle from the back to this front left face. Always comes out perpendicularly, and the data never changes shape, right? So if it starts, the data starts as a parallelogram on the back like this, it's going to end up as a parallelogram on the front like that. So just a very quick version of, I'll do this freehand, but you guys are obviously going to do the same operation where you pull all the data out. So the positive version of that data from the back looks like this. Right? And the negative version taken from the cube. Looks like that. Okay, so same operation. So positive and negative subtractions. I would recommend doing them on vellum like I did this one. Just make sure that where you place it, I had to actually take the edge of my paper around edge of the board because I didn't set this up right in the middle. You set it up right in the middle, you should be fine. But there's our positive data, there's our negative data. A nice archival version on vellum is recommended with the nice profile line. And then you should have basically 2 nice drawings for your portfolio. All right. Talk to you guys on Monday. Thanks very much.